Question: which scikit-learn model can be directly used for predicting multiple continuous outputs simultaneously? A. Linear regression. B. Random forest regressor. C. Gradient boosting regressor. D. All of the above. Linear regression is a model that can handle multiple outputs but directly predicting multiple outputs simultaneously is achieved through the multi-output regressor class. False. Similar to linear regression, random forest regressor is capable of predicting multiple outputs, but the multi-output regressor class enables simultaneous prediction of multiple outputs. False. Gradient boosting regressor also supports multi-output regression, but the multi-output regressor class simplifies the process of predicting multiple outputs simultaneously. False. All the models mentioned linear regression, random forest regressor, and gradient boosting regressor are compatible with multi-output regression. They can be used with the multi-output regressor class to make predictions on multiple continuous outputs at once. This approach streamlines the prediction process and avoids the need to build separate models for each output. True. D. All of the above. Multi-output regression is a technique in machine learning used for predicting multiple continuous target variables simultaneously from a single set of input features. It's particularly useful when the target variables are related to each other and can be effectively modeled together. Imagine predicting the price of a house price and the square footage of the house SQFT based on features like location, number of bedrooms, and bathrooms here. Both price and SQFT are continuous target variables that are likely related. Scikit-learn sklearn is a popular Python library that provides various tools for machine learning, including a wide range of algorithms, pre-processing techniques, and model evaluation methods. In this case, scikit-learn is used to import the model's linear regression, random forest regressor, gradient boosting regressor, data splitting functions train test split, and performance metrics mean squared error. Linear regression is a basic and widely used model in machine learning. It assumes a linear relationship between the input features and the output variable. It aims to find the best fitting line or hyperplane in higher dimensions that minimizes the error between the predicted values and the actual values. A simple example would be predicting the price of a house price based on its size SQFT. The linear regression model would find a line that minimizes the difference between the predicted prices and the actual prices. Random forest regressor is an ensemble learning method that combines multiple decision trees. It improves prediction accuracy and reduces overfitting by averaging the predictions of individual trees. Each tree is trained on a random subset of the data and features, introducing randomness into the model. To predict the price of a house, the random forest regressor would create several decision trees, each trained on a different subset of features and data points. It then averages the predictions of these individual trees to arrive at a final prediction. Gradient boosting regressor is another ensemble learning method that sequentially builds multiple decision trees. It starts with a simple model and iteratively adds new trees that correct the errors of previous trees. The new trees are trained on the residuals errors of the previous predictions, leading to a strong and robust model. In predicting house prices, the gradient boosting regressor would initially build a simple tree and then add new trees to improve the accuracy. The new trees would focus on the areas where the initial tree made the most errors, effectively refining the prediction process. Multi-output regressor is a wrapper class in scikit-learn that allows for predicting multiple outputs simultaneously. It takes a single estimator like linear regression, random forest regressor, or gradient boosting regressor and replicates it for each output, making predictions for all targets at once. When predicting both price and SQFT of a house, the multi-output regressor would create two instances of the chosen model, e.g. linear regression internally. Each instance would be responsible for predicting one of the target's price or SQFT. The multi-output regressor ensures that the model is trained and makes predictions for both targets simultaneously. Multi-output regression finds its application in various domains where predicting multiple related target variables is essential. These scenarios often involve complex systems with interconnected factors, predicting multiple financial metrics, predicting stock prices, interest rates, and economic indicators simultaneously can be valuable for financial forecasting and risk assessment. Predicting weather variables, modeling temperature, humidity, wind speed, and precipitation together allows for more comprehensive weather prediction. Predicting machine health metrics, monitoring various aspects of machine performance like vibration levels, temperature, and pressure can help anticipate maintenance needs and prevent breakdowns. Predicting customer behavior, understanding customer preferences, purchase patterns, and churn likelihood simultaneously can help optimize marketing campaigns and customer retention strategies. Predicting multiple properties of materials, characterizing materials like strength, density, and elasticity simultaneously is crucial in engineering and materials science. The code snippet demonstrates how to utilize the multi-output regressor class in sklearn for multi-output regression. It iterates through different models: linear regression, random forest regressor, gradient boosting regressor, and uses multi-output regressor to train and predict multiple targets simultaneously. The code uses a synthetic dataset, make regression with 2 input features and 3 target variables. It splits the data into training and testing sets, trains the models using multi-output regressor, and evaluates the performance using mean squared error (MSE). The output shows the mean squared error for each model, indicating the accuracy of the multi-output regression predictions.